Can see a few people still trickling in. Welcome. It looks like the rate of arrivals is beginning to steady out, so I'm going to kick us off. Kia ora koutou katoa, ko Kimberly aho, kei te Sustainable Business Network aho e Mahiana. I'm Kimberly from SBN. I lead our climate work, and I'm delighted to be welcoming you all today for this webinar with Professor Tim Naish, Antarctica to Aotearoa, Climate Risks and Your Business. I'll open us with a karakia, then we'll have a tiny bit of digital housekeeping before I introduce Tim and hand over to him. If you know the karakia, feel free to join in. We can't hear you, but we will know that you're with us. Tu taua mai I runga, tu taua mai I raro, tu taua mai I waho, tu taua mai I roto. Kia tau ai te mauri tū, te mauri ora ki te katoa, homie, huie, tai kie. Welcome again, everybody. Thank you for being here. We're delighted to be hearing from Professor Tim Naish today. Tim is a Professor of Earth Sciences at Victoria University of Wellington. He plays a leading role in Antarctic research and climate science. His achievements and accolades are too many for me to list off here, but he was a lead author on the Intergovernmental Panel of Climate Change Fifth Assessment, and he's recently returned from a trip to Antarctica. So we're very lucky to have him sharing his time and expertise today, and he has some really important and interesting messages to share with you all. We'll have time for Q&A at the end of his presentation, so please do put questions into the Q&A box on Zoom. You'll find it near the chat on that bottom panel. I'll be monitoring and passing on your questions when we get to the end. Thank you again for being here, and over to you, Tim.
Yeah, kia ora koutou katoa, ko Tim Naish toku ingoa, ki te mahi aho te whariwānanga o te Hetaringa Waka, Victoria University of Wellington. Thanks for the introduction, Kimberly, and great to be here. I will now negotiate the sharing of the screen, which means I need to push that button there, that one there. Yeah. Sorry, I'm saying that out loud. Here we go. Right. Just give me the thumbs up, Kimberly, if that...
Perfect.
Does that look good? Perfect.
Yeah.
Okay. All right. So Kimberly and I were talking about this presentation and what we should cover. And so we've come up with this title, Antarctica to Aotearoa, and the climate risks associated with not just global climate change, but particularly the role Antarctica plays in that, and then what that means for us. And in the case of the Sustainable Business Network, what that means for business, which is not too dissimilar to what it means for communities and people in dealing with climate change. Okay. Oh my God. Yep, there we go. So most of you being in the business community will be aware of the World Economic Forum, and each year they come out with this global risk report. This is not the most recent one, and you know, the business world, the money world, certainly see climate as, when you look on a 10-year time scale, the climate crisis as the world's greatest existential threat. And if you look at the tables in here, they list the top 10 risks. Well, the top 4 are all environment and climate related, and they relate to failure to mitigate, which is something we're seeing playing out right now with our failure to deliver on the Paris Agreement. There has been some success, but not enough. Failure to adapt, and then, of course, the cost and damage from natural disasters and extreme weather events, combined with the general biodiversity loss and ecosystem collapse that we're seeing happening. So this was summed up recently in a conference I went to, and I can't remember who the speaker was, but they were from the United Nations Environmental Programme, and they talked about the impending nexus of the climate crisis, the biodiversity loss, and environment degradation. And I think we're all aware, while there are certainly really immediate threats in other spheres of our lives, whether they're geopolitical or potential for warfare. Those risks are acknowledged by the World Economic Forum, but if you look at a decadal timescale, these are the things we're going to have to get on top of for our future sustainability and having a climate resilient future. And of course, just touching on those other risks we're facing, it's complex now. Sometimes it's called polycrisis, but we really are facing multiple risks from all directions with increasing frequency and compounding and cascading impacts. So yeah, it's complicated, but we'll just tackle the climate one in this talk. So you'll all be aware of this. 2024 was the hottest year since records began. And that's taking us dangerously close now to some tipping points in the Earth system that are around 1.5 to 2 degrees of global warming, which is no surprise that the United Nations Framework Convention on Climate Change decided in the Paris Agreement that we really don't want to cook the planet above these temperatures, because the science tells us we're going to get some long-term, irreversible and serious impacts. So here we are approaching, having approached 1.5 degrees and last year, and looking to be on track for another one this year, which has sort of got us a bit stumped in the scientific community, because last year was an El Nino year, and I'll talk about why that makes the world hotter in a minute. But this year's a La Nina year, so we wouldn't expect the same rate of warming we're already seeing in January and February. So yeah, the direction of travel is still up and not good. So let's focus on what that means for Antarctica, which is really the topic here. And New Zealand's, I'm part of a really vibrant Antarctic research community in New Zealand that's still relatively well funded, could do better. And we're really well connected internationally and really at the forefront of some of the science and the impact, understanding of the impacts that are coming from change in the Southern Ocean and Antarctica. So Antarctica sits down here, as we all know. Many of us have never seen it. Scientists like myself are very privileged to have got down there and to see the change and to be working on the change. But essentially a massive lump of ice sitting on continental bedrock. If you took the ice away, this is what it sort of looks like under Antarctica. We know this from being able to image through the ice sheet using mainly airborne radar techniques. But we see that it's got these sort of areas of where the ice sheet sits in the blue, well below sea level. So the ice sheet is sitting on bedrock, but below sea level in the West Antarctica, in this part of East Antarctica, and this part of East Antarctica. We generally think of West Antarctica as being highly vulnerable because most of it sits deep below sea level, and the ocean around Antarctica is warming. So we expect West Antarctica to be the first one to really respond to this global warming and the warming ocean. And the reason that is because we've had 1.2 degrees of global warming on average. We've had 1.5 last year. And that's from the burning of fossil fuels, which I'll come back to. It's because of us. But the heat from the burning of fossil fuels has largely gone into the ocean. 93% of it has gone into the ocean, and about 70% of it into the Southern Ocean around Antarctica. So in a way, if we didn't have the ocean, our planet would have warmed by 35 degrees, not 1.5 degrees, 35 degrees. It would be unlivable. So in the way, the ocean heat sink has been a buffer to the warming, runaway global warming we could have had. Unfortunately, all that heat being in the ocean and concentrated around Antarctica is a problem for the Antarctic ice sheets, which sit below sea level and in contact with the ocean. So if we lost the West Antarctic ice sheet, and many would argue that that's already underway and can't be stopped, certainly for parts of it, that's altogether about 4 meters of sea level rise. And if we lost the East Antarctic ice sheet, I've just realized there's a there's a mathematical error there. We would get 54 meters of sea level rise, not 5.4 meters of sea level rise. So that's the East Antarctic ice sheet over there, decimal points in the wrong place. So we're not going to lose all the East Antarctic ice sheet in the near future because a lot of it is very high, cold, and well above sea level. But parts of it are vulnerable, like the Recovery Basin here and these basins here. So these are the areas of the Antarctic ice sheet we're getting increasingly concerned about, and that's where we're seeing most of the change. And if all these areas went, then we would be committed to 22 meters of global sea level rise. And I'm going to talk about tipping points in a minute, but there is a distinct possibility that if we will warm the world more than 2 degrees and we keep it there, we will commit to the irreversible loss of ice out of those areas and ultimately be committing the world to 20 odd meters of sea level rise. Won't happen overnight, and I'll talk about how much and how fast in a minute. But that's the big issue with Antarctica. So as I said, the heat from global warming has so far gone into the ocean. And yeah, I've sort of explained this slide. And, in a way that's buffered global warming, but it's all around Antarctica now, up against the Antarctic ice sheet. This warm ocean water is starting to nibble away. And 25% of the carbon dioxide has gone into the ocean, which again, you might think is a good thing. It's not the atmosphere causing global warming, but it's causing ocean acidification. And some of our equatorial coral reefs are very close to an irreversible dieback situation. So let's come back to the ice sheet and let's explain what that means to us as the ice sheet changes. And there's sort of a basic lecture I would give my students is the different types of ice on Antarctica. First of all, we have the ice that sits high and dry on continental bedrock above sea level. And here's a huge glacier up on Antarctica. And that's we call that land ice. It's sitting on land, and a majority of the Antarctic ice is sitting on land. And if it melts, it contributes to sea level rise because you're taking the ice cube and putting it in the ocean and causes the ocean to rise. As the ice flows out to the edge of the continent, this land ice, it starts to float. And that's when we get a floating glacier tongue or an ice shelf forming. And those ice shelves are very important, and I'll explain in the next slide why. But they help stabilize the ice sheet and hold the interior ice sheet back from flowing into the ocean. But these ice shelves are melting around Antarctica because of the warming ocean, because these ice shelves are floating, the ocean water is getting underneath them, and they're beginning to break up into large icebergs or even disintegrate, and they're getting thinner and much less volume. And that's a big issue for the ice sheet behind it that causes the sea level rise. Then there's the frozen ocean. And this is simply seawater. The Southern Ocean around Antarctica freezes every year because it gets dark and cold. And you get a big apron of sea ice. And that's simply the ocean freezing. And then in the summer, that sea ice melts again. That does not cause sea level rise because it is already ice that is already in the ocean. Likewise, once the icebergs get in the ocean from the ice shelf calving and collapsing, these icebergs, when they melt, do not cause sea level rise because they're like the ice cube in your glass of gin. If you don't drink the gin and you just watch the glass, which is a hard thing to do, I appreciate, but if you don't drink the gin and the ice cube melts, the level of the glass won't change. And that's the same with icebergs. But what really does matter is the volume of ice coming off the continent. And that's what causes sea level rise. So as I've explained, we're deeply concerned about parts of the Antarctic ice sheet that are sitting below sea level and are being in contact with an ocean that is warming, and particularly along the West Antarctic ice sheet here. And you can see this pink area represents ocean warming and over the last few decades. And this is the loss of ice shelves over the last few decades. And you can see, well, the red dots just mean a lot more of the ice shelves have been melting. So you can see we're losing the ice shelves around the West Antarctic ice sheet. Not so much around the East Antarctic ice sheet, but it's starting to happen. So this is the area where if the ice shelves do go, and it looks like they're well on their way, once they go, then the ice sheets, the West Antarctic ice sheet is very exposed to a warm ocean. And as that warm ocean eats away at the grounding line at the edge of the ice sheet can melt irreversibly and very, very rapidly. And it's essentially an unstoppable process. So, maybe another way of thinking about the ice shelves, and remember, these are the floating extensions of the ice sheet as it flows into the ocean. The ice shelves form a buttress that holds back the ice sheet. So here's an ice shelf in the Antarctic Peninsula. These are the glaciers on land, and this is the floating ice shelf. And you can see it forming a lot of cracks. You can see it, those blue areas are meltwater, and this is from surface and ocean warming. And then you can see within a month, that whole region disintegrated. And this is a big area. This could be the size of, say, Northland, just disintegrated. And after that, the ice on land flowed into the ocean 10 times faster. So we think of these ice shelves as a stabilizing buttress, a bit like a Gothic cathedral. That church here on the left would not stand up without these flying buttresses holding it. You take the buttress away and the church falls down. You take the ice shelf away and the ice sheet just slides into the ocean. So the really critical thing is, when will we lose all the ice shelves, or enough of the ice shelves that we can't stop the ice sheet essentially flowing into the ocean? That's a big topic that we're working on. It creates uncertainty in our future projections. It creates uncertainty when predicting sea level rise, and we'll talk about that. So the runaway meltdown of the ice sheets happens when the ocean water gets in and melts the ice shelves, these floating extensions. So this is the warm ocean water upwelling onto the continental shelf, getting into the cavities of the ice shelves, melting the ice shelves, and then the ice sheet itself starts to retreat, thin, and retreat. And this process is unstable where the ice sheet is sitting well below sea level. So what do we do with this information? Well, we try to understand the processes, and then we put equations to the processes and put them into computer models. And then we run these computer models forward for a given climate warming scenario and see what happens to the ice sheet. So I'm going to show you two scenarios, and I'm sure you've heard of them. One is the Paris scenario, where we keep global warming below 2 degrees. That'll be on the left. And there's a clock here from 1950, so it'll be retrospective, and then it'll go through into the future centuries. On the right, we have the very warm scenario that the IPCC puts out, which is the RCP 58.5. So I'm going to spin these up together, and this is the blue area is the ice sheet, and you can see the ice shelves are these gray areas. There's the Ross Ice Shelf. And essentially, you're going to see changes in the blue area depending on which scenario. So I'll get this one going, and I'll get this one going. And on the left, remember Paris. On the right, remember burn, baby, burn, drill, baby, drill. Both scenarios are unlikely, but we can come back to that, in that we're not achieving Paris, and we're probably not going to get the worst case scenario. Okay, so I don't know if you noticed, but and I'll run these again, but when we got to the year 2100, this one on the right, we lost the whole of the West Antarctic ice sheet, and then we started to lose these big bites into the East Antarctic ice sheet. And by the time we get to 2300 with this model, sea level's 15 meters higher. That's only, that's only 3 centuries away. This one saves the ice shelves. So the message, the hopeful message from this model is that there's still not too late to save the ice shelves. There's a bit of a debate as to whether we'd lose a bit of West Antarctica, but we could keep Antarctica intact if we limited global warming as close as we can to 1.5 degrees. And it just turns out, I'm not showing you the in-between scenarios, but it turns out that the tipping point for ending up with a world looking like this or an Antarctica looking like this is about 2 degrees of global warming. So we go above 2 degrees of global warming. We don't have to be on the worst case scenario. We are going to end up with commitment to multi-generational, multi-meter sea level rise. We achieve Paris, there's a good chance we lower that risk significantly to less than a meter of global sea level rise. So that's in a nutshell, the problem. And if you're a business or if you're a decision maker, you're a local council and you're trying to think about coastal adaptation and your risk, you've got to deal with this large uncertainty. And we'll come back to that. And it's related to the Antarctic ice sheet. There's lots of concerning warning signs going on right now that are sort of almost precursors that tell us we're very close to this tipping point. And one of them is the sea ice. Remember I mentioned the sea ice? It forms every winter and it goes out on typically in the depths of winter by September. The sea ice is out at that orange line, and then in summer it melts away. So I've just been down in Antarctica, and I went in a ship into this region, and you couldn't get there in winter, but in summer you can because the sea ice goes away. Likewise, the Ross Sea is accessible, and I'll show you a video in a minute. But the point of this slide is to show you that in 2024, it was the lowest extent of winter sea ice ever. So it's about 30% less than what we usually get. And this is a trend that's been going on since about 2017. And there's a question as to whether we are now at a point where the winter sea ice is never going to come back to its biggest extent. It's just going to retreat more and more, much like the Arctic sea ice has. And so I'll just spin this up, another model just showing an animation showing, you can see the Antarctic continent, but this apron around it of white frozen ocean is the winter sea ice getting to its maximum extent in September. And then this is a simulation from 2009. And then as we go into spring, it starts to shrink, it starts to break up. Here's the Ross Sea opening up. And by the time you get to summer, that winter sea ice is all gone. The problem we're now facing is it's not reforming. And if you don't have winter sea ice and you don't have sea ice in summer, you don't reflect the incoming solar radiation and you heat the planet, you heat the Southern Ocean even faster. Another thing we're seeing happen in Antarctica, which is of a concern, is for the first time we're seeing extreme weather. We're seeing heat waves. This place was thought to be impenetrable to heat waves because it's just such a cold, icy place. But what we're seeing is these atmospheric rivers, these warm streams in the atmosphere of moist, warm water coming out of the tropics and out of East Australia and dumping moisture on Antarctica. And this is a temperature record for a place high in the East Antarctic ice sheet, where there's a weather station. And this is an annual temperature record. And this is usually what happens. It's warm in summer, -30, not that warm. And then it gets cold in winter, -70. But in March 2022, in one day, we saw a 38-degree warming. That it was still cold, it was still -11.8 degrees, but that is the biggest one-day heat wave warming anomaly ever seen or recorded on the planet. Now, that's the big blotch where it happened over East Antarctica, but had it happened over West Antarctica, which is much warmer and much lower, you could have seen catastrophic widespread breakup of ice shelves. And so we're now realizing that it's not just the background of global warming that's causing the issues. The trigger could be one of these heat waves coming in and one of these atmospheric rivers and dumping warm air on Antarctica that starts to kick things off in a way that triggers tipping points or a series of these heat waves. Right. Now it's time to get into the impacts on New Zealand, and I'm watching my clock, Kimberly, so you just give me a 5-minute warning or something. I'm probably going to need about another 5 or 10 minutes. Is that okay?
That's totally fine. Thanks, Tim.
Thank you. So this is pretty cool. It's an old Landsat image, but you can see the cyclones that develop around Antarctica, and you can see New Zealand up here. A lot of our weather, we know it, we feel the southerlies, we get the snow on the Southern Alps. In Wellington, we get a southerly regularly. Our Antarctica is a major driver of New Zealand's climate. So yeah, we know that. We feel it. But really, New Zealand's climate is really a tug of war between the cold air and weather systems coming up, cyclones and weather systems coming up from Antarctica, and the heat and the subtropical influence coming down from the tropics. And so, you know, we're right in the mid-latitudes in the middle of this, and we can think of it as a bit of tug of war. So with global warming, the majority of the energy is coming into the equator, and then it gets pushed poleward. So that's the engine room. That's where the heat's coming in from global warming, the majority of it, and it gets pushed towards us. And Antarctica pushes back because it's cold, and there's this thing called the ozone hole, which I won't go into in great detail, but the ozone hole has been helping keep Antarctica cold, because with the ozone hole open, you get a lot more cold stratospheric air mass on the continent, and it keeps the sea ice growing. But that's all changing. The ozone hole is closing up, and the greenhouse gases are winning out, and the push from the equator is winning out. And with that, New Zealand's climate is more and more being influenced by a contraction of the cold from Antarctica and an expansion from the north, from the tropics, with the warm air coming in. So one of the consequences of change in Antarctica is not just sea level rise, that's one of them. The other one is that it's affecting our weather and our climate and allowing the tropics to dominate our climate more. And we know this because we're getting more and more cyclones such as Gabriel coming out of the tropics and extreme weather events. So what are we in for? And I'm just going to spin through this relatively quickly. And what can we do about it? Okay. So this is what I'm talking about, is that the tropics are expanding and we get air masses and warm ocean currents out of the tropics that come around New Zealand. And these currents, we know from geological data, we know from 125,000 years ago, these currents really did intensify down the east coast of Australia and started to really dominate New Zealand's climate, warming the ocean. We're already getting these ocean heat waves, but they were really a big deal the last time we had 1.5 degrees of global warming, which was 125,000 years ago. So this is where our ocean heat waves come from, is the tropics pushing down through the Tasman front and pushing these warm currents around New Zealand. But also associated with the expansion of the tropics are an increased frequency of what we call extratropical cyclones, cyclones that develop in the tropics, but then come down and hit mostly the east coast of the North Island. And Gabriel, of course, is the biggest natural disaster on record, climate-based natural disaster. And we had that in 2023, but we also had Hurricane Hale or Cyclone Hale. So 2 big tropical cyclones in 2023. We are now receiving these atmospheric rivers. Remember, I talked about these affecting Antarctica. Well, they're now regularly affecting New Zealand, and the Auckland anniversary floods was an example of an atmospheric river. Essentially, a pipeline of warm water from the tropics that got concentrated over the North Island and on Auckland, and they got an incredible amount of rainfall in a very, very short time. And these atmospheric rivers have affected Nelson. They are a new phenomenon of the tropics getting warmer and funneling that heat and moisture down to New Zealand. So the two big new terms you hear a lot about are cyclones, extratropical cyclones becoming more frequent, and atmospheric rivers becoming more frequent. And here's an example of the mid-August floods in 2022 that affected Nelson. It was a blocking high, focusing an atmospheric river into New Zealand. So one of the things that really matters for us is the El Nino La Nina climate pattern. You hear about this all the time in the weather and the news. Are we in an El Nino year? Are we in a La Nina year? Well, last year we were in an El Nino year. And in an El Nino year, the world is warmer because the ocean gives off more of its heat to the atmosphere. And in a La Nina year, the world is cooler because the ocean holds on to its heat. These are natural climate cycles on top of a background of global warming. And you can see on the global temperature record, every time we've had an extra warm year, it's been during an El Nino. Even although the overall background is going up, the spikes are driven by El Ninos. So for New Zealand, that means we get a warmer year. Our temperature record is warmer. It usually means we get a bit more rain in the west and droughts in the east. And in a La Nina, our climate is generally cooler, but we get more extratropical cyclones. So during La Nina, when the ocean is holding on to its heat, the tropical influence expands even further onto New Zealand. And it was a big La Nina when we got Gabriel and Hale. And we're seeing a very strong pattern that when we go into a La Nina year, we get hit by an extratropical cyclone. And we are heading into a La Nina year this year. We haven't seen it yet, but we're only just hitting cyclone season. So there'll be those who say, and I'm sure you hear it in the business sector, oh, you know, haven't we always had extreme weather events because of El Nino, La Nina, or natural variability or whatever? And the answer is no. I mean, the answer is yes, but we're seeing many, many more of them. So this is just something I developed from the NIWA Extreme Weather website. And basically what I'm showing is in the 70 years up to 2004, which includes the Wahine disaster and Cyclone Bola, there were only 5 extreme weather events. Then in the next 10 years, there were 6. And in the last 4 years, there have been 10. So you can see the trend to increasingly more damaging and costly and deadly extreme events in New Zealand. And so, yes, we have had extreme events in the past, but now they are part of our new normal. And we can't be in disaster response mode constantly. Whereas in the past, maybe you could deal with a disaster once every 20 years. But now we have to be front-footing this and thinking about how to make ourselves more resilient so that we're not building back in dumb places, we're not putting people at risk, and that we are recognizing that these extreme events are just going to get more and more frequent. I know I'm watching, Kimberly. I'm getting close. So these are just what we can expect in New Zealand. This is summarized from the information the IPCC puts out and NIWA puts out. And this is really the good news story. If we get 2 degrees of global warming, we're going to get 5% more rain in the West. And actually, it's not a good news story because that makes the tropical cyclones and the atmospheric rivers significantly more frequent and intense. The wet places will get wetter and the dry places will get drier. With 2 degrees of global warming, which is the best we can hope for, we'll get 40% more hot days. Those are days above 25 degrees. Drought occurrence will triple. Wildfires, we're already seeing the impact of wildfires, and this is something I think New Zealand's been caught out by. Our emissions reduction strategy and the emissions reduction plan is to grow a lot of forests. And so this is going to be something we're going to have to manage, is wildfire. We're already seeing this in a big way in the North Island, but also in the South Island with the retreat of our snow lines and our glaciers and the implications that has not only for the tourist industry, but for our water supply, our water security, our hydro lakes, and our ability to irrigate and crops. Now, sea level rise is the one that I'm supposed to be talking about, and this is something that is happening already. It's been happening for the last 100 or so years since the Industrial Revolution, since we've been using coal, oil, and gas. And this sort of shows the historic sea level rise, and there's an acceleration in it. And we've seen about 22 centimetres over the last 100 years. A third of that is coming from the ocean expanding and heating up, all that heat that's gone into the ocean. A third is coming from the melting polar ice sheets, and a third is coming from the glaciers melting in the Himalayas and the Andes and the Southern Alps. But the glacier, the land ice component, and the polar ice sheets are getting into the driver's seat, and they are really accelerating, and they will drive future sea level rise. So how much will we get? Well, this is what the IPCC says. By the end of the century, best case scenario, 50 centimetres, can't avoid that. Worst case scenario, 1 metre. However, if, like I showed you in those models, if some of these processes of rapid irreversible retreat happen in the Antarctic ice sheet, then we are looking at up to 2 metres. The IPCC said 2 metres could not be ruled out by the end of the century. So this is what our decision makers are dealing with, and we know by mid-century we're in for about 20 or 30 centimetres. We can't avoid that. We know at the very best, if we achieve the Paris target, we've got to be prepared for 50 centimetres of sea level rise. But it could be 2 metres if we go through a tipping point and cause the irreversible meltdown of parts of the West Antarctic ice sheet. So that's a very challenging thing to plan for. And I haven't got time to go into it today, but in the coastal hazards guidance for New Zealand, Ministry for Environment's coastal hazards guidance, it advises decision makers a process on how to deal with this uncertainty in making their plans. I'll just basically, the point here is our greenhouse gas emissions are still going up, and they've been doing that while a lot of talk has been going on at international summits over the last 30 years, and a lot of science has been done. And there is no pathway to achieving a safe climate that doesn't involve complete phase out of coal. Coal is still 46% of our CO2 comes from burning coal, and it's a huge contributor in the electricity sector. So this sort of stuff that happened at the COP 2 years ago, where there was a suggestion we could get there without phasing out coal, is rubbish. It absolutely has to be phased out, and a rapid phase down of oil and gas. Now, let's give ourselves a small bit of positivity. Here are the global emissions, and you can see that they're starting to plateau out. So they are slowing down, and if we achieve what we've pledged at the Paris Agreement, if every country delivered on it, we'd end up with 2.8 degrees of global warming. It's still a lot, but it's not 4 or 5, which is the worst case scenario. But it's still a big if. Countries have to deliver on their pledges, and they have to actually improve them to get them down to 2 degrees. But if we look at what countries are doing, and we think about Trump and we worry about his impact on climate change, the USA has made progress in their emissions, regardless. And we've had Trump before and we've got him again. I'm not saying that this won't change, but this is the historic pattern. The EU, England, the UK have done well, but China are the really big polluters. India can't sort of help this because of its situation. And but overall, we're starting to see a slowdown. The rate is still the highest it's ever been, 55 billion tonnes of carbon dioxide per year, but it's not increasing as fast as it used to. We have a plan. I won't go into great detail. I'm sure you've read the emissions reduction plan. Our plan is incredibly unambitious. It just involves essentially planting trees and buying carbon offsets with turning our electricity sector 100% renewable and trying to electrify our vehicle fleet. It's not considered sufficient. It's considered highly insufficient globally, and it's a problem for New Zealand. We don't have clear decarbonisation pathways that will work. We are also at risk, and so I'm going to round up here, Kimberly. I'm not going to get all through all my slides, but the message here is that this is just the risk from sea level rise, and there's a lot at stake, and you can read about this in the Coastal Hazards Guidance, which has recently been updated. The point now is that it's not just New Zealand. The world is backsliding on mitigation. Paris target is looking like it's going to fail. And there are more and more, the Paris Agreement, there are more and more countries threatening to walk away from it on the back of the USA doing this. And so the rhetoric is really now around how do we protect ourselves? And that's coming out of our current government. How do we protect ourselves? Adaptation to what we can't avoid is an absolute critical issue for the world and for New Zealand. But no pathway to a safe climate can be done with adaptation alone. We must still do the best we can on reducing our emissions to get the global warming as close to 2 degrees as possible, although that's not looking so possible right now. In New Zealand, tools are becoming available to help with planning. And one of the issues for New Zealand, of course, being a coastal nation, is sea level rise. So you can go online here. Many of you might have seen it. You can zoom into on a little dot near you. You can see for the different climate scenarios how much sea level rise you'll get. But this also takes into account the fact in New Zealand, the land is sinking in many places. So that exacerbates the rate of sea level rise. So what this shows is a dashed line for Lowry Bay, Petone. By 2070, you might get 30 centimetres of sea level rise at best case scenario. This is for the Paris Agreement. But if you add in the rate that's Petone sinking, that's going to occur, that 30 centimetres is going to occur much faster. And so this is one of the important points when planning for sea level rise around New Zealand. It's just one example of a risk from climate. Your local factors really matter, and you might not have as much time as you thought. So in Wellington, we thought, 30 centimetres by about 2070. Well, it could be as early as 2040. Just so happens that around the Motu, 30 centimetres of sea level rise means the 100-year coastal flood will happen every year. And that will mean that some areas will be inaccessible and serious adaptation options will need to be looked at. I'm not going to go into all of this. I will make this presentation available, and there's just some information here. And I was going to talk about the policy settings in New Zealand at the moment and how they're really changing, and they're changing around the world. And it's not good for our action, the critical action needed for climate change. And there are legislative and various constraints you all work under, both at the national scale, but they're driven from the international scale. And there are some guidance and plans available to deal with that. I won't go into that. I'll let you just read it. And this is my laundry list when people say, what can I do about it? And this is something useful to take away. It may not be so useful in the business world. I think it all applies, actually. But if from a personal point of view, and we're all individuals and humans and part of this problem, there's some takeaway points there. So sorry, Kimberly, I really have put too much into this, but I'll make those slides available, and it'll be better stop, and have some questions.
We've got a few. Thank you, Tim. It's a huge amount to fit into the time and so important. So I think everyone has been Fascinated. I will ask a couple of questions of you now, and we'll try and get the rest over to you for perhaps some quick email answers afterwards for those we couldn't reach.
Yeah.
So first question, is the storm surge effect higher with higher sea level rise, or does that remain the same? Is it going to get worse the higher the seas go?
Yeah, so the issue with storm surge around New Zealand is that we are not the wave climate will waves will get a bit higher with global warming, but the frequency of inundation will increase as we rise sea level. So that's why right now in Petone, we're getting these big events every 50 years, but with 30 centimeters of sea level rise, those big events will happen annually. And that's partly because certain areas will be permanently flooded, but but the frequency of inundation just continues, to increase. Yep.
And a related one on wanting to understand the impact. Is it likely that there'll be more extreme cold weather events, or are we only looking at extremes of hot weather?
Yeah, well, it is likely, and the Northern Hemisphere are seeing this. And there's been a World Meteorological Organization put out a map of the world showing where the heating had happened, and there was some in 2024, and there were some cold spots. Iceland is one that got cold, and we know that we're getting these crazy snowfalls in places like Houston and Texas, and that's a function of global warming because the jet stream's getting wobbly and unstable, and you're getting these cold incursions coming out of the Arctic, and we'll get them. We've had a few of them actually coming out of the Antarctic, but they're unusual. And when they happen, people go, "Whoa, that's weird," but they will occur. But as the greenhouse gases get more and the world warms, they'll be less and less important, and warming will be the major feature, not the cooling. Yeah.
One further question on some of those impacts you talked about. How often do atmospheric rivers tend to affect us? And perhaps I'll add on, is that likely to change in the future?
Well, I've just said yes. I wouldn't want to put a number on, like everyone wants to know when is the next Gabriel coming and when will the next Auckland anniversary floods come. All I can say is they are becoming a frequent feature, certainly in the last 10 to 15 years. So the general statement for New Zealand, and would be wonderful if we could predict these things, is that get ready, and particularly in La Nina years, for increased effects of atmospheric rivers and extratropical cyclones. It wouldn't be crazy to see an atmospheric river and a Gabriel scale cyclone every year we had a La Nina. That's how serious it is. And that's a big issue, is that, how many cyclones before we go, oh, we shouldn't live here anymore.
Mhm.
And if we get 2 or 3 years without another cyclone, we might start getting confident that, oh yeah, this was just a one-off thing. But the people need to understand that that these are now becoming the new normal.
And from what you just said, it's not that we're going to get only one of those types of impacts, right? We might have the cyclone on top of the river, or also the impact of those storm surges and sea level rise. So we should be thinking about those risks alongside each other, not in isolation.
Absolutely, and I didn't really get on to the compounding risk and hazard, which you're well aware of, and we see it that usually, if we get one of these low pressure systems, big cyclone, we get a storm surge, and so that causes coastal flooding. Plus, we get the massive rainfall, which causes land river flooding, and if you're in what we call the coastal sandwich, if you live on the coast, big city on the coast like Hawke's Bay, in the Hawke's Bay, that you're getting it from all angles. And so in risk assessment these days, councils are trying to get to grips on the multiple cascading hazards. And that's actually really difficult. The science, we're not doing well in providing tools for users. that we can provide a sea level tool, we can provide a river flooding tool, but putting them together for a certain area is a challenge for us at the moment, and we know that's what you need.
Are there people beginning to work on combining those things?
Yes, absolutely, absolutely. And there are sort of statistical approaches that are already being used, but the chat, to say, what's the probability of this and this occurring at the same time, and what would be the impact. But the thing we really want is physical models that we can actually model the catchment and see. South Dunedin's a classic. When it gets a massive rainfall event, it gets surface flooding because the groundwater is so shallow, and often the pipes infrastructure can't handle it. Now, as they get sea level rise as well, that's going to push the water table higher. So there's no point doing one without the other when you're doing your risk assessment. And that's really what our research is doing. We have a big research program working on those, and NIWA are a key player in that. And it's a real challenge for New Zealand to do better in the science community at pooling our resources. Yep.
No, thank you. And we'll make sure when we email everyone out after this webinar that we include a few links to those existing resources and guidance that you've mentioned.
Yeah.
There are several more questions, but in the interest of time, I'm just going to ask you one last one, and we'll see if we can get the rest to you over email. In this context, you mentioned a little about what we can do. How confident are you that we can afford to take action and that has a chance of actually being impactful to the future consequences we face? Is it still worth it? Should we be doing mitigation and adaptation together? What's your take?
Yeah, the most important question, and absolutely positive that there is still time. And with that sea level tool I showed you, we still have decades. So that's what that tool gives you. It gives you a time frame to put in place the appropriate adaptation, method. Globally, adaptation just gets harder if we don't mitigate. So globally, everyone has to do their bit on mitigation. And there is a sense of, no one's doing enough. But that's why I showed you that things are plateauing off. We're not going to hit the worst case scenario. Yes, there are questions as to whether the models are right. Maybe we're under sensitive, but it's looking like we shouldn't cook the world more than we should be able to prevent the world warming more than 3 degrees. And we really must do that. And then we have to adapt. And there is time to do that. One of the biggest issues we have is their will to do that. And it requires systems change. It requires governance from the government, our institutions, to not kick this around every election cycle like a football, but to say over the next 30 years, 40 years for New Zealand, we are going to put in place an adaptation policy that involves moving some communities away from the coast over time, involves putting in protection where necessary, and spreads the cost and is worked out with the insurance sector, is worked out, and it gives business confidence because they know there's a plan that isn't going to be overturned every time the government changes. But I personally have hope. I believe the science says we've got time, but the question is, will we be proactive and do it, or are we just going to remain in disaster recovery mode, which won't be good for the world?
Thank you. I think that question is one that today we're putting out also to our attendees. Are we going to be proactive? I know by showing up to this, all of you on this webinar have indicated that you're interested in paying attention, you know the need to act, and I think you are among the people who are going to be. So thank you so much, Tim, for filling us in on some of those risks we may not have been aware of. I'm going to close us out with a couple of notes from SBN on that what do we do about it piece, and we will circulate a copy of this webinar afterwards. So for those who are now sitting there feeling that urgency and wondering what do we do about it, Tim gave a fantastic summary of that system level picture, some concrete places to start, and knowing that for all of us, this is going to be something that we very much need to continue learning and engaging with and understanding. If you're here on this call representing an organization, what can you do? You can take action to reduce your emissions. That mitigation piece came through loud and clear. You can work on regenerating nature, helping make sure that we're not degrading our world further, that we're keeping the natural resilience of ecosystems. You can assess your risks and make a plan, and we'll share some resources after this, including that guide that Tim mentioned. And you can work together to push for those changes Tim was talking about that we really need to happen fast and with urgency. SBN, of course, is here to help with those things. We strongly believe in all of these types of action, and we have a number of ways that we can support you. We have trainings, and thank you so much, Tim, for being part of this piece of information sharing and education. We can also support you one-to-one with advisory, and we've contributed to a number of tools and resources that will be included in our follow-up. So if you're thinking, what does climate action look like for my business? How could I reduce emissions? You may want to check out the Climate Action Toolbox as a starting point. If you're thinking about how to get to grips with risk and adaptation planning, tomorrow, ClimateWise will be launching with guidance on adaptation planning for smaller businesses. It's going to be a great resource, and I highly encourage you to check it out when it goes live tomorrow. And most of all, keep paying attention, keep looking for the changes that you can make, and thank you for showing up today to be a part of that. I'll close us out now with our karakia, and thank you all again so much for being with us today. Unuhia, unuhia, unuhia ki te uru tapu nui, kia wātea, kia mama, te ngākau. Te tinana, te wairua, ki te ara tangata, koia rā e rongo, whakairihia ake ki runga. Kia tina, tina, hui e, pai ki e. Thanks again, Tim, and everybody. Have a wonderful rest of your day, and let's get cracking.